Are you hearing me? I'm asking.
We can, sir. We can, sir. Go
Yes,
ahead.
sir, we can hear you, sir. We can hear you, sir.
Okay. So now, what is a lubricant? Or what is a lubrication? Lubrication is the process of reducing friction and wear between moving surfaces in contact. I will try as much as possible to break every word down so that everybody can understand it. When we say lubrication, we say friction. Friction means that force, that negative force, that retarding force that can make you as if you are going backward. It's like you are running, your maybe wind is making your effort not to be counted. That is what friction means here. So there is friction in every machinery that is moving, that is rotating. So in order to deal with that friction, to remove that friction within lubrication system, to make sure that friction is what removed. We are not moving totally, but we are trying to reduce it. And that process of reducing this is called lubrication. It involves introducing substances such as liquid, gas, solid, and semi-solid or plastics to the mating area. How do I mean? Why are you saying solid? How can you use solid to store lubrication? We'll explain that later on, right? The lubrication is the process of or technique of using a lubricant to reduce friction and wear and tear in contact between two mating surfaces. Adequate lubrication allows smooth, continuous operation of machine elements, thereby reducing the rate of wear and prevent excessive stress or seizures of the bearings, all right? When the lubricating oil is poured in between the mating surface, it forms a fluid film, which keeps the two parts separated from each other and reduces the amount of friction. What that part is saying is that when two mating surfaces, even those our gear, we think they are mesh. That language, that meshing word, that word mesh, in the English, it means they are meeting. But in real life, they don't meet. No two gear ever meet. No two plates ever meet. Even the so-called sliding plate, they don't meet. There's always a gap in between them. Invisible gap. That is where friction comes in. If they meet in 20 seconds, they will burn off. But there's always what we call lubricant in between. Even if you just see that lubricant, they just know that there's air. That form of lubricant that's in between, including your pump. If you shake your neighbor, no matter what, your two hands are not jamming. If you are clapping when you are clapping in the church, your two hands are not jamming. That is what science is saying. In the word of lubrication, they are telling us that if you have to put your two together, there is a gap in between. And that gap, lubrication is there. Otherwise, as you are grinding your hands, the two hands will be what? Will be falling away, will be wearing away. So friction, which is the result of wearing or tearing or reduction of two components that are meeting, is only put to control or under control when a lubricating substance is added. And that's what this very one is all about. When lubrication breaks down, components can rub destructively against each other, causing heat, local welding, destroying damage, and failure. When I say local welding, that means when two metals begin to rub against each other continuously, it will be hot. A time will come, it will become red hot. At that red hot, it will be forming molten. 1 million metal will become almost liquid. At that point, two metals can join together and form one single metal. And that is what you get when there is no friction. And when you apply the right friction, that one will be what arrested, will be contained. And that's what our topic is all about this night, right? Imagine a workplace without lubricants. Machine will grind to a halt, engine will seize up, and process will stop. In this section tonight, we will talk about the complex world of lubricants, clarification, and selection, shedding light on the crucial role lubricants play in keeping our mechanical running and smooth. Hello, someone is talking at the background. It is a well-known fact that all machines or engines have an assembly of components, and some of them are in motion and in contact with each other. Due to the rubbing action of these components, there is an excessive production of heat. Frictional forces are generated, which oppose the motion, causing a loss of power, excessive wear of components, and in due course, failure of the components. What are the functions of lubrication? Why do we talk about lubrication? Why do we use it? Why do we introduce it to our materials in our industry? The first function of lubrication is it reduces frictional force between moving components. I told you somewhere, as if you are moving forward as a sprinter, you are running, all your energy that you are using to run, you would have gone further, but there is one of frictional force that is pulling you back, which is the air, the breeze, the wind that you are seeing. It takes you back. That's exactly what friction does to equipment. Equipment that will be running smoothly because it has an opposite force that is doing a background task under the same task. If equipment that is able to run 100%, we only end up running at 70%. So by applying lubrication, you remove that friction, thereby making that equipment to improve its efficiency from that 75 maybe to 90, if not 100%, right? Then number two, it reduces the wear and tear of components. Number three, it increases the lifespan of the machine and edge components. Number four, it reduces corrosion of the component. When we say corrosion, what do we mean by corrosion? Corrosion, to corrode. That is the external wearing away of a component. This you can easily see in this our vessel, our machine, our metal parts that are exposed to the salty water, or even the one that is under the atmosphere. This everyday dew, you see this dew, they will rest on your machinery. The next day, they will dry when sun is shining. What is happening? There will be a gradual corrosion. If your vehicle, if you park your vehicle for a long time, if you don't drive it, because water is entering every morning in the form of dew and is drying up, it will be corroding it. That is external wearing away of the components. The lubricants act as coolants. How does it do that? The energy components are cooled by removing the heat produced due to friction. Then the other one say it washes away all deposit formed due to wear between two surfaces and thus helps in cleaning the surface. Then the next one, it provides mechanical sealing between two parts. Yes. I told you just now, every two mating components, there is a third one. That third one is the lubricant. It helps to seal it up, like your shaft and your bore. There's no matter how tight fit a shaft is installed, there's always what we call a clearance fit, a clearance that is given. That clearance has a purpose, it serves a purpose, and it is just coolant or it is your lubricant that seal up that clearance, thereby form the third mate or a third component, so that every one of them, the two gear or the bearing and the shaft, will now be rotating with the lubricant at the middle. Then the next one, it reduces metallic noise in energy component. We understand that without lubricant, there will be noise. It was metal to metal. When metal to metal is grinding, it will make noise. Because there's lubricant, as it's removing your friction, it's also what minimizes your noise that it generates. Let's go to the next slide. The principles of lubrication. When two machines components are in contact and they have relative motion with each other, even though the metal surface is made smooth by machining, there are always a lot of abrasion found in between. That's roughness. What I'm saying that no matter how smooth a component is, there's always some degree of roughness. In other words, in science, there's no component that's 100% smooth. It has some degree of deformity of roughness, which means you can only get as close as 98% of that metal. Is never 100% smooth. So that roughness is usually found during you understand it better if you have worked on the flanges. No matter how smooth the flanges, it needs a gasket. Because if you bring two flanges together, no matter how smooth they are, air, that is gas or fluid or oil, will always pass, no matter how you tighten your torque, how you torque your bolt and nuts, because they are not actually as smooth as you think. That's what I'm saying, right? If the machine components are loaded and lubricating oil is introduced into them, the load will try to force the lubricating oil layer out of the surface, and this results in metal-to-metal contact. Due to some technical reasons, Some clearance is always provided between two surfaces of shaft and bearing mating gearing, so that when the shaft rotates in the bearing, it is lubricated by pouring lubricating oil in between that hole of your ball and your shaft. And in most cases, if I were assuming you can see me, let me see if I can bring my, so I can explain to you. Where's my listing? My video. Can't find it. Okay. Then we are seeing the principle of lubrication. When the shaft is at rest, hello? I'm asking.
Okay, here.
Okay.
Can hear you.
When the shaft is at rest, what that means, you have shaft in your inside your bearing or inside your ball at a horizontal level, a horizontal shaft. To us, we think the shaft will stay at the middle. No, it does not always stay at the middle. When the machine is done operating, the shaft will tend to rest at the basement. As you can see in this picture, this is number this is B, this is number A, load A. This is how every shaft behave in your ball. When I mean ball, your hole, that hole that you put your shaft. Maybe let's inside a bearing, let's call this bearing, and this is your shaft, all right? It will not stay at the middle. I'm trying to use to exaggerate how it look like. A shaft and a bearing, the hole there that you are seeing, even though you think you are forcing it in, there's always some level of clearance that is what they call it tolerance fit. That is what created during design phase. The purpose of that is that to make sure during operation, that place will permit the entrance of your lubrication, all right? So when the works don't be done, when the equipment is in the off position, all your lubrication will go to the sump, for example. No one will remain there. Will be the shaft that will not rest on the basement of your hole until you start again. By the time you start the equipment, the oil will, through the help of a pump or any other means of feeding the lubricant, will now tends to fill this space. Because as you start the machine, as the shaft is rotating, it will lift itself up from that basement to almost at the middle. All right. Then thereby creating the clearance. That clearance will now be filled by lubricating oil. What oil does that is to make sure there is no physical contact between the shaft and the bearing, thereby preserving the lifespan of both the bearing and the shaft. Otherwise, if there's no such gap, in less than 30 seconds, no matter how strong that shaft is, it will burn off. So you say when the shaft is at rest, there is a metal-to-metal contact. When the shaft rotates, the lubricant tends to raise up the shaft into the bearing due to centrifugal action. The lubricant occupies a slightly eccentric position in between the two surfaces. I just made that down, right? Then you see this one. This is how every surface look like. No matter how you think they are smooth. This surface one and that's surface two. These are two plates, all right? In between here, this is how every surface look like at the mating end. They are never smooth, but when you look at it with your normal eye, they tend to look as if they are smooth. But when you use a microscope to look at it scientifically, this is what you get. All right, this space is where our lubrication is filled in through enemies. All right, without lubrication here, in less than, before you know it, this place will become widening when they are rubbing against each other. When they are doing sliding motion, if they are sliding against each other, before you do it, this one of them, the one that has a better strength will remain. The one that has a lower strength will wear out. And if the two have the same strength, they will wear at the same time, right? So in order to avoid that, we have to feed in lubricants here. That's what I'm saying. Then understanding lubrication. Different substances can be used for lubrication on surfaces, but oil and grease are the most common. Grease is composed of oil and a thickening agent to obtain its consistencies, while the oil is what actually lubricates the system. Oil can be synthetic, can be vegetable, can be mineral, or as well as what combination of this. The application determines which oil, commonly refers to as base oil, should be used. In necessary conditions, synthetic oils can be beneficial. What does this mean? This synthetic oil, some call it chemical oil. What about the rest oil are more of mineral? The one when you say mineral, the one you mine from crude oil that you refine your refinery. is this mineral. When you see mineral, that's mine. Why this vegetable oil is the natural oil? Now we use vegetable. Actually, I would have used the natural oil here because it's a combination of both the nature of a vegetable and animal fats. Like this pattern oil, the one we use in the village, that the one they call ori is under this group. Then other vegetable oil like your avocado pear, your rapeseed, and other vegetable, even your palm oil fall into this vegetable oil, right? Then in extreme conditions, synthetic oils can be what beneficial. What this means, there are some equipment. No, can I go first? There are some equipment that you cannot use a normal vegetable oil. Instead, you go for this synthetic oil because at extreme, when it's extreme condition, when the temperature is very, very high or when temperature is very, very low, so sometimes this mineral oil will fail you. They will not do the work of lubrication again. So you need a synthetic oil that is prepared specially to meet that what condition. Where the environment is of concern, vegetable-based oil may be utilized due to its eco-friendly nature. This one is about when the environment is of concern. Sometimes there are some of these food processing companies where equipment are also being run. You know, some foods. You know, there's no we can use a mineral oil as a grease or as a lubrication in some food industry. So instead, you look for vegetable or natural or based lubricant as your source of what? Removing your friction or removing your excess heat, because should there be mixture or should there be contact with those lubricants and your food that you are producing, it will not be harmful to anybody. That's what we say. Where the environment is of concern, vegetable-based oil may be utilized due to its eco-friendly nature. Because even when your vegetable oil mixed with your food, it could not harm the person that is eating it. That's what I'm talking about, right? The method of lubrication, apart from proper selection of right lubricants for specific purpose, an effective method of applying this lubricating oil is also necessary for any machinery. For example, we have 4 here, but later we'll talk about this more, right? There are more than 4. At this level, let's use this for manual lubrication, gravity field lubrication, force lubrication, and splash method lubrication. This is when you see manual field. Manual lubrication by oil can, that is the one you put the oil in your small rubber, then you'll be spraying it, comes under this category. Also, application of grease by brush and other means by hand fall into this category. Then gravity feed lubrication. In gravity feed, lubricants are supplied by gravity. That is, you put this oil on top of where you want to feed it. So what's called orifice under the can that houses your oil. As the machine is working, the thing will just be coming gradually, in a controlled way, so that the quantity you want will just be entering. Sometimes in your machine shop, this is what they use the gravity feed, right? The force lubrication. In the force lubrication, the lubricating oil is supplied at high pressure by an oil pump. This is what we use in our vehicle, in our motor engine, in our turbine and other things. We call it force lubrication, right? The oil is at the sump underneath the engine, and where this oil is needed is on the top of the engine. So you need a pump to pump it or to give it energy or momentum for the sun until you get to the gallery where they are needed. They do not fall back to the pump again, to the sump again. Then the last one, splash method of lubrication. When you say splash, this one is also a part of it's also found in your engine. This one means it's in the form of oil bait. You allow the oil, as your engine is rotating, there is something that is connected to your crankshaft. It's like a dipper. It dips itself into that place and scoop the oil up. It's like a scooper. I scoop oil up. As scooping it up, it's making the oil to circulate around those periphery, around the engine crankshaft, around your connecting rod, and those other components that you cannot see easily. That is facing down, even up as far as to your piston area. It flushes the oil upward, and the oil will just go up and come back. That's what we call splash method of lubrication, right? But we'll still talk about this in our next video, right? This is just more of a preamble, introduction aspect. What is this? I must be hard. Then during the course of our training, there are some tests we'll be using more often. Hello? Hello?
We can hear you, sir. You can
We
continue.
can
Yes,
hear
I can hear
you,
you.
sir.
Okay.
We can hear you.
As is, during the course of our training, there are some terms we'll be using more often. There are lubrication terms or more of engineering terms, right? Or technical terms. The first one in this thing is tribology. When we say tribology, it says it's the study of friction, the study of lubrication, and the study of wear. That is three. THR means three. So three means lubrication, friction, and wear. When you combine those two together, studying them at the same time, they can call you a tribologist, right? Then friction is the force resisting the relative motion. I told you just now, when you are running, that tends to pull you backward. That's not making you to have 100% of your energy. Is what we call friction, right? Then we have three kinds of friction: sliding friction, rolling friction, and what fluid friction. The sliding is the most dangerous. When you have two flat surfaces coming together, they are sliding. When they slide, they are grinding on each other. Slide means to move forward and back, for example, move front and back, move front and back. So there will be this direct contact of the two objects or the two flat surface. So they generate the highest form of friction, right? Then the next one is what rolling friction. This rolling friction means instead of you having those metal to metal meet together, you now put some rollers like some cylinders in between them, so that it will now by putting that cylinder between them as they are rolling now, they are not rolling on top of the cylinder, on top of those rollers. So there's no more direct contact between your first plate and your last plate, thereby reducing the first sliding friction to a mere rolling friction. So if your sliding friction was consuming maybe 60% of your energy before, when you now apply rolling friction, you will be consuming, you will reduce that friction from that 60% that you were consuming for your heat to maybe as low as 20%. That's what rolling friction will do. But it's also not the best. It's a further one, the one called fluid friction. This is where the lubrication comes in. Lubrication doesn't mean it doesn't mean absence of friction, but it means friction being brought to its barest minimum. All right. So you now use this fluid friction, you are actually trying to make sure every other is like in your hazard control. You have option to select from. You are either using elimination, you are using substitution, you are using engineering, you are using PPE. What about now, when you are not using this fluid friction, it means you are using everything to make sure you bring that your friction to the barest minimum. From 16 before now to 4 to 20, now from 20 to 5%. That's what your fluid friction will do to you. So you have put everything there. You are now also creating space for you to put your oil or your fluid or your grease as it be, to make sure the friction, which is that your energy waster in your system, is being brought to the barest minimum, which to some extent you can say is negligible in science, right? Then wear, what is wear? Wear is the damage or gradual removal or deformation of bacteria at solid surfaces. So wear means, as for example, as you are in those days when we're in the village, when we want to go to farm, you get a cutlass and a file. As you are filing your cutlass without your file, or even on your stone, you see as the equipment, as the cutlass becomes sharp, some particles will be dropping. That's wear. That's one good example of a what called wear, right? Then to reduce that, and now in the language of lubrication, to minimize that wear, what causes that wear is that there's heat that is being generated. That heat in between that exists between your cutlass and your fire is what is actually responsible. This is the reason why the equipment that your cutlass and your fire will begin to grind themselves. They will be grinding themselves because there's no friction in between. But our parents then, they will not add little water to your cutlass. As they're not sharpening, you will not be seeing more of that wear, but the cutlass will still be sharp. Whereas in the real life, that water they add is just be soluble water. Water mixed with the substance. What that does is what minimize the rate of wear, minimize the friction. And when you minimize the friction, you also automatically minimize rate of wear. That's what I say. So wear is the gradual damaging or gradual removal or deformation of material at solid surfaces. The next one is lubricant. When you say lubrication, anything that you use to carry away this your excessive heat or friction is what we call lubricant, right? Lubricant is a sleeping liquid or gear or oil that is used to reduce friction between meeting components. Then corrosion. When we say corrosion, what is corrosion? To corrode. That is to corrode. Corrosion is from corrode. All right. To corrode means what? That external wear that takes place when your metal is exposed to the atmosphere. The effect of that atmospheric condition to your metal is called corrosion. Or, for example, if you park your car for a long time outside and that car is not painted, no, let me use car now. If you park any metal object outside that is not painted, in 3 days, it will first form what we call it will begin to become it will become red-like. It will form oxide of that metal. That formation of oxide of that metal is corrosion. Then sometimes if those of you that work in the IC, when your vessel is backed by the key side for a long time, and is inside the salt water, that salt water has its power to begin what to corrode. Will I use that? To attack your metal plate of your that body of your vessel. Before you know it, with time, that vessel, the thing was very powerful. Leakage will occur if that corrosion is not treated properly, right? The next one is force. Force and friction, they are always the same. Force is one of the positive aspects, while friction is the negative aspect. A force is an influence that can cause an object to change its position. It is measured in Newton or other units as agreed by what ISO, International Standard of Organization. Then bearing. The term bearing is derived from the word to bear. To bear means to support or to take all the authority of another. A bearing is a component that constrain or that compare or that force relative motion to only the desired motion and reduce friction between what moving parts. This bearing comes in different form, right? The part of the bearing is what? Instead of especially in the horizontal shafts, that you use to support your shaft to make sure the shaft does not grind on your bore or your hole, to make sure the shaft rotation is not in zigzag form. That is called bearing. So I don't know. Those of us that worked in machinery will understand that better, right? So the basic category is a bearing is a component that constrain or that force relative motion to only the desired motion and reduce friction between what moving components or moving parts. Then viscosity. This one we'll deal with it more of, right? There's a topic. There's maybe as we portrays, I will talk more on this viscosity, right? At this level, viscosity is a measure of fluid resistance to flow. All right, viscosity and friction, they are almost in the same family, right? Resistance, the measure of that resistance, there's a friction, but the measure of that friction is viscosity, right? Then viscosity index, this one talks about the behavior of your lubricant over the temperature range, right? Maybe at 10 degrees, how does your oil behave? At 20 degrees, how does it behave? At 100 degrees, how does it behave? That range, that behavioral pattern, that behavior of the oil, and that measure, that behavior, that description, that oil behavior is what we call viscosity index, right? We're going to talk about it later. Then lubricity. Listen, before I talk about what I talk about tripology. Now I'm using another term again, lubricity. Lubricity is the measure of the reduction in friction and wear by a lubricant. The measure of the reduction, right? If I put oil, just I told us that we start with a sliding friction. When I reduce sliding friction by applying roller, what have I done? I want to reduce the friction. The time I use oil again, what have I done? I also want to reduce the friction further. Then if I use this oil, they have grade by grade. So there are some that are far better in terms of friction reduction. So that measure of those oil capacity in reducing friction is called lubricity. Hope that is clear. Then shear stress, the ratio of the applied force to the area of the plate. This shear stress is more of a negative pressure, all right? Pressure is a force by area. So shear stress is also what force by area. We'll be using this during our calculation. That's why I'm just putting it here now, right? So that It will be strange to us when we do our calculation right later on. Then velocity gradient or shear rates. The ratio of velocity to the separating distance of the meeting plates. Two plates, when they slide, there's a velocity, but the distance is what called that ratio between the sliding of that plate and the distance separating those two plates is what called the shear stress or velocity gradient. All right. Then additives. So these are substances that are added to another substance in order to improve or preserve their what? To improve their performance or to preserve them. So when we talk about the grease and oil formation, we also what? We use some more of, right? Then thickener. Thickener are substances that are added to mineral oil to form grease. Watch this one, additive. We add additives to another thing to what to improve them, to improve their performance. But thickeners are added to form grease. Can you see it? This one to improve their performance, or this one we add it to form what? Grease. This one, so if it don't have a purpose, just to form grease. What now is to improve their performance, all right? So we'll talk about it later on too. They help to turn liquid oil into semi-liquid what substances. That's what thickener does. It's like when you are making soup, those of us from the village, from maybe Delta or Edo, when we are making a owo, we use account, what we call account, potash, to turn your palm oil into thick fluid that you can use to eat your food, all right? That's what thickener does here. It's just it, all right? So we'll also explain later. So as I told us, these are the terms we'll be seeing more for as we go for that. So when they come, I don't need to explain them. You already know them. If you don't remember, during your time of your going through your slide, your documents, when you are at your free time, you can go through them again, and then from there you know what each one represents, how they are interrelated. The next one is what is a lubricant? We've talked about the lubrication. Now we're talking about lubricants. Lubricant is a substance that helps to reduce friction between two meeting faces, all right? Thereby reducing the heat generated when the surfaces move and stopping meeting components from rusting, that's corrosion, often shortened as lube or lube oil. The process of reducing friction is known as what? Lubricity. The process of reducing friction is what lubricity. We are going to look at lubricants from several points of view as follows. Brief history of that lubricant, classification of lubricant, composition of lubricant, and selection of lubricant, right? The first one is the brief history. Let's talk about the brief history. How does it started? Who are those that started it? Did it start with our generation, or the generation before us, or not after us, or many years ago? Yeah, from this history, we'll talk about it, right? So a brief history of a lubricant. How it all started. Lubricants have been in some use for thousands of years, knowingly and unknowingly. They were using it cautiously and unconsciously. As far back as 400 BC, that's once at 400 BC, after the death of Christ, or BC means before Christ was born, we were already using a lubricant. Imagine that as of chariots were lubricated using calcium soaps. They use calcium soap then as their lubricant. Then palm oil and other Asian lubes were used during building to slide stone on iron, to slide stone on oil impregnated wood pole in the time of the pyramid of Egypt. In the Egyptian days, when the Egyptians were in power, where the world power, they used palm oil as a means of making their job easy during the building of their pyramids. They might not even know what they were doing then, but they were using this palm oil as their source of a lubricant then. Then lubrication was also used to prevent intruders from getting access to any kingdom. Can you imagine? They were also using lubrication as a means of fighting your enemy. As in the case of the kingdom of Great Benin in those days, in the 1580 BC, in the 1580, palm oil were used to rob the Great War, to slow down. You see, when you have grease, when you have oil or lubricant on your road, if you step on it, you can maybe make it to fall. So those guys that are so wise, they use this lubricant to rob the wall. Because then in those the wall surround the whole land of Benin Kingdom, so that nobody can enter. So they use lubricant to rob those walls. So when the intruders are coming, they will find the wall to access. Because you cannot climb because it was always slippery. Every now and then they were men whose job was to rob those walls to make it look creamy. And the more creamy it was, the more difficult it was for enemy to climb to access it. In the Roman era, during the reign of the Roman Empire, lubricants were made from olive oil and rapeseed oil, as well as animal fats, like this pattern oil. The growth of lubrication accelerated in the industrial revolution of the Great Britain with the use of metal-based machineries, relying initially on natural oil. Needs for such machinery shifted towards petroleum-based materials in the early 1900s. In the 90s, when oil was discovered, then they shifted from natural oil to mineral oil. So though we still use natural oil, especially in our pharmaceutical industries, in our food processing industries and smaller industries, where food that are consumed are manufacturers, they don't always use mineral oils. They use natural oil. When you say natural oil, that's vegetable oil and animal oils and animal fats. A breakthrough came with the development of a vacuum distillation of petroleum during this is our era in the late 60s and early 70s when we started having these refineries. So that was when lubrication became very, very lucrative and became a business of its own, right? This technology allowed the purification of substances which are common in many lubricants. How are lubricants made? Typically, lubricants contain 90% of base oil. When I say base oil, I mean mineral oil from crude, all right? And 10% of additives. What is additives? Those things, I told you that additive means those things that you add to another thing to improve their performance. Base oil alone cannot serve the purpose of a lubricant. You need something else to be added to it. So that's where additive comes in. So this additive, we also to talk about it. It can come in different shape and in different form, right? Then the next one is what? Vegetable oil is synthetic vegetable oil or synthetic liquids are sometimes used as a base oil. Then you bring this and you add additive to it. All right. Once additive is added to it, become what? A lubricant, or it become a what? A lubricant, right? Additives are added to reduce friction and wear. So the base oil cannot reduce friction and wear. So you need to add additive in the right percentage, in the right ratio to increase viscosity, that is ability what? To reduce friction, to improve the viscosity test, its ability to what? To withstand temperature and pressure, to cause or create resistance to corrosion, oxidation, aging, and what? Contamination. When you talk about corrosion, when you use this corrosion now, I would have used the word erosion here instead of corrosion, because this is what happens inside the structure. When there's wear on the outer surface is corrosion. When there's that same wear inside the surface is erosion. As in, I will use pipe for example. That external attack on the pipe is corrosion, but the internal attack on the pipe is corrosion. So that's what this one does. There are things you add to your liquid, to your fluid, such that as the fluid is passing the internal structure of your metal, it will not corrode it or it will not erode it. It will not wear it. Whether corrosion or erosion, what they do is they attack the metal, they wear it. So when you add additive to it, it will slow it down or it will even eliminate it. They will remain the way they are. All right. Then they also have to stop aging or contamination. Lubricants are generally composed of most of the base oil and a blend of additives to impart desirable water characteristics. Although generally lubricants are based on one type of base oil, mixtures of the base oils are also used to meet performance requirements. Classification of lubricants. We'll talk about classification also. Now, lubricants can be classified into 4 distinct categories based on their physical state. The first on the list is what? Liquid lubricants. The next one was semi-solid lubricants. The other one is what? Solid lubricants. And finally, gaseous or gas lubricants. But I think we'll talk more about this liquid and semi-solid. These other 2, if there's time, we'll also talk about it, right? Each category possess unique characteristics and application in various industrial and mechanical processes. No matter how smooth a surface is, there's always a level of what? Associated roughness. Hence the need for lubricant. I told you just now, no matter how smooth a surface is, it's only smooth to some degree. Maybe 99%. It's never 100% smooth. That by making it necessary or wise for us to introduce lubricants. Because if they were 100% smooth, you would not need lubricants. Because it's not 100% smooth, if you don't need applying lubricant, because that's a little degree of roughness, they will be better to be that contact, which will lead to wear or deformation or degradation of that or those metal that has this thing. So what I just said to you that in the diagrammatical form is explained like this. Lubricants. I told you, we have solid, we have liquid, we have solid, semi-solid, solid and gas. Am I right? Under the liquid, we have natural gas or natural oil, mineral oil, and extended oil. Under the semi-solid, we have grease, just grease in that family, that category. The under solid, we have a copper, liners. This is a liner. This is a when you heard of this liner bearing before in your crankshaft, in your connecting rod. Those bearing, even those are spacer, those are Teflon spacer. They fall into this solid board lubricants. They have aluminum. Then for gas, we have air, nitrogen, and helium. These are the three major type of a gas lubricant, right? Copper, liner, and aluminum are the major kind of a solid lubricant. While grease, under semi-solid, is just grease. Then for liquid, we have a natural oil, like in your, when you say natural vegetable oil, like your avocado pear, like your honey, your animal fat, even that your pattern oil, the one they call the ori, they are under natural oil. Then your mineral oil, your normal 20 W50, 50 W40, your azo oil, they fall under this mineral oil. Then synthetic oil, they are this chemically formulated oil, like your synthetic hydrocarbon, SH, those hydrocarbons that you made through combination, through chemical mix, fall under this what? Synthetic oil. Then we'll talk about this. Then if there's time, we'll talk about this and this also. All right, also, they'll call it the right. Am I still being heard? Hello, sirs. Hello.
We can hear.
We can hear you, sir.
Okay,
We are following.
thank you very much, all right? Then
We can hear you, sir.
we'll start with a liquid lubricant. What is liquid lubricant? Liquid lubricant represents the most widely used category of. Sorry, let me pause this. Liquid lubricant represent the most widely used category of lubrication materials in industrial applications. This includes, first on that list is what? Mineral lubricant. Mineral lubricating oil, which I told us now. Then synthetic lubricating oil. This bio-based or natural oil is animal or vegetable. The water-based of this one introduces, because sometimes most of us we also work in this turning stage of machinists. Machinists uses most often water-based lubricants. You get a fluid and add more water to it to suit your cutting purpose. All right, but in other, this 1, 2, 3 are used in the oil and gas industry most often. But this about 4 is used also, but not common in the oil and gas. Rather, it is used in the machine shop. Whether in the machine shop or oil and gas, they are all lubricants. So they are what listening to and what telling us about. All right. The liquid lubricants are commonly used due to their broad versatility range, enabling precise selection for mechanical components operating under varied loads, speed, and temperatures. This versatility allows for optimized lubrication across the industrial process and machinery. The first on the list was mineral lubricating oil. Currently dominating the market, mineral oils account for approximately 90% of total lubricant volume. They are derived from crude oil. These oils are formulated by blending refined petroleum products with performance-enhancing additives. The additives typically include anti-wear additives. That one, you add anti-wear to your lubricant, to your oil, to make sure it helps to stop that rate of wear, to minimize it. We have antioxidant. We also add additive to your lubricating oil to make sure it helps to fight against that formation of your ferrous, of your iron, for example, iron with oxygen. You know, when iron mixes oxygen, it will not be iron. If not be what ferrous of iron, and that ferrous of iron is very dangerous. It's not good. We want the iron to remain as iron. We want the metal to remain as metal. If you want that to happen, you will add what antioxidant additives to your base oil. Then the next one is corrosion inhibitors additives. This one will help you to fight the corrosion, the rate of corrosion. when you add it to your lubricant, the other additive that I say is viscosity modifier. This modifier will help you to make sure you extend the life of your engine oil in your vehicle. For example, there are some engine oil that can only withstand 30% of temperature increment. But with the introduction of your viscosity modifier, it will improve that oil to be able to withstand temperature, even when the temperature become as high as 84 degrees Celsius. That's what this one does, right? Then this helps to tailor the oil's properties to specific application. Then the next release was synthetic lubricating oil. Synthetic oil is a lubricant consisting of chemical compounds that are artificially modified or synthesized. Synthetic oil is used as a substitute for petroleum refined oil when operating in extreme temperature. Synthetic oils offer superior lubricating performance characteristics compared to mineral oil. Yes, when you talk about extreme temperature, like extremely cold or extremely high, where your normal mineral oil will break down, synthetic oil what we find its usefulness there. There are advantages of using synthetic oil over mineral oil. The first one is better at low temperature and high temperature. That is when the temperature is very cold or very high. Then viscosity performance, it helps you to improve the oil performance also, right? Then better higher viscosity index, it helps you to improve what the additive does in your base oil. Synthetic oil can do better when you're using synthetic oil. That's what I'm saying. Then chemical and shear stability, no matter the condition, it will not allow the equipment, the surface of your metal to start pitting, to start wearing or to start rusting, corroding. All right, that's what the method is talking about. Then it has some disadvantages. Anything has advantage, it must have what the merits. One of the merits what synthetic oils are more expensive by volume than normal mineral oil. They can decompose easily. Okay, they are more expensive because they are chemical. They can easily decompose, but they're not natural. They are artificial. When you say synthetic, it means artificial. All right, because they're artificial, yes, they will do what they want to do, but they will end up creating another problem. But when they decompose, they will not be seen as oil again, they will be seen as something else. So we'll talk about that later also, yeah? Then bio-based. This one talk about vegetable oil and natural oil, right? Made from animal fats or plant sources. These environmentally friendly lubricants are gaining popularity due to their biodegradability and renewability. Rapeseed, soya beans, palm oil are common vegetable-based lubricants. Bio-based lubricants have been found to exhibit superior properties over the conventional mineral oil. Imagine that. With renewability and biodegradability being their strongest suit, they are also eco-friendly. When you say eco-friendly, even when you eat it, it doesn't harm anybody. Even if you come into contact with your body, it will not harm you. Even if it's on the environment, if you're on the environment you're working, it's eco-friendly. It will not harm it will not pollute the environment. That's what I'm saying. Even if you maybe during your course of your work, it started raining, then they push it to the high sea. It will not kill your fish. It's eco-friendly. All right, that's what I was saying, right? Then water-based fluids. This lubricant incorporates water as a key component, offering excellent cooling properties and fire resistance. I told us that this one is used mainly in our machine shop. They are categorized into two main types: soluble types, water-soluble compounds dissolved in water, e.g. glycol and solution. All right, that thing you see when you say glycol, that's a chemical or that's a liquid that you see inside the gauge, inside the pressure gauge or temperature gauge. That thing is called glycol. It's a form of oil. If you remove that oil, you mix it with water. That's what they use in your machine shop to cool your turning machine or your drilling machine. All right. Then the next one is emulsion type. Oil in water in oil. This one is oil in water, right? Oil in water is OW, or water in oil, WO, emulsions. Stabilizes by emulsifier. So when you say emulsion, it means you are trying to make sure when something you say emulsion, it cannot mix with water easily to form another compound or another chemical as it may be, which you will use that will give you a better result than when you use it as normal water or normal oil, right? Good. Then the next on the list was the second type of a lubricant is semi-solid lubricant, otherwise known as grease. Grease is only grease is in this category. Semi-solid lubricants, commonly called grease, exhibit a unique consistency between solid and what liquid states at standard temperature and pressure. What I mean is that sometimes this grease, sometimes you see it as liquid lubricant, sometimes you see it as what solid lubricant. That's why it's called semi-solid. It can also be, if it's semi-solid, it can also be called semi-liquid, because it's in between. In fact, the first three class of grease are actually semi-liquid. They are more of liquid, they can flow. While the last 6 are the semi-solid, which are more of solid, because they don't flow. So these lubricants are characterized by their mixture structure, typically consisting of a thickening agent spread in a liquid lubricant-based oil. Grease are actually a liquid lube that have been mixed with a thickener at the right proportion. They are liquid, but when you now add your thickener to it, thickener will now make it to become thick, to become either semi-solid or almost solid, as the case may be, depending on the proportion that you added. While liquid lubricant only have base oil and additives, grease, on the other hand, has base oil, additives, and thickener mixed to form semi-solid substances. Grease are typically composed of about 80% lubricating oil, then 5% to 10% thickener, and now probably 10% to 50% what additives in most common greases. All right, this is how they mix them. We have, so the bottom line is that grease composes of 3 items: base oil, additive, and thickener. So at this proportion, 80, 5% or 50%, or 80, 10%, and 10% to make it 100%. Can you see it? If your oil is 80%, which is normal, your thickener should be 5%, then your additive should be what? 50%. If you have 15 to 10 to 5 and 80, it give you 100. Otherwise, if your base oil is 80% and your thickener is 10%, your additive should be what? 10%. So if you have 80 plus 10 plus 10, you will be also 100%. So that ratio, your ability to ratio it at the right ratio, then to your ability to apply that at the right ratio will determine whether your grease you are getting is a light grease or a heavy grease, all right? That's what I'm trying to explain here. To prevent drying out at high temperature, dry lubricants. What am I? I'm not. What am I? Semi-solid 24. To prevent drying out at high temperature, dry lubricants are also added. By selecting appropriate oils, thickener, and additives, the properties of grease can be optimized for a wide range of applications. These are grease. They are greases suitable for high or extremely low temperature, vacuum application, water resistance, and waterproof grease, highly pressure resistant or creepy types, food grade, or exceptionally adhesive greases. What I say that during your mixture in the right proportion of your oil, additive, and your thickener will determine what function or what role your grease will play in your machinery preservation, right? So if you need it to carry away excessive heat, there's a way you mix those 3 components together. If you need it also to carry away to stop corrosion, there's a way you mix it together. If you need it to carry excessive load, there's a way you also mix it together, right? That's what I'm saying. Then grease possesses several key properties that make it irreplaceable. Up to now, we still use grease because of this property that it possesses. First one, adhesiveness. Its ability to adhere to metal surfaces provide excellent protection against wear and corrosion. Imagine, grease is like when you put it in your equipment, why expect that when the equipment is working, the grease will start throwing away? It will not throw away. That's a good quality of grease. And that is possible because of the thickener you're adding. That is what we call adhesiveness. Then water resistance. We believe that sometimes when we apply our grease, like in your sliding surface, like this is our equipment, like our crane and our forklift. These things, they are under the atmospheric condition. The rain beat them, the dew work on them, even dusty area, and so on and so forth. Yet, those grease, the water will not stop them from what performing their function. So one would have expected that when it rains, the rain will wash it away. No, it doesn't wash it away. Why? Because of the presence of your thickener. Then number 3, sealing capability. Grease can act as a barrier against contaminants. Once there is grease, especially in the end of your, when there is no seal, in the end of your shaft and your bearing, because there are grease there, no dust can penetrate the grease. It will act as dust stopper, as contaminant stopper. At the same time, it will still be performing its function as grease, as a lubricating property, yet it is stopping dirt from entering. Then extended lubrication. Due to its semi-solid nature, grease tends to stay in place longer than liquid lubricant. Why? As you are using the grease, that your thickener is acting as a sponge, it's acting as a foam. You know, when we bathe children, with little children, we use food to bathe them, you put sponge, you use your foam as like sponge, you apply soap under your sponge, under your foam, you use to bathe your child. You will not be pouring water on the child body. You will use that same soap you will use to pack water and wash the baby. The water will go out. You will use to pack it again. And you what the grease does. The thickener act as a soap, as that foam or as sponge that you use to bathe your child. It will not allow the oil, the grease to pour out completely. As the grease is going out, as the oil, because the oil and the grease is what lubricates, not the grease. The grease, those 3 things, additive and thickener, they serve a purpose. But the main thing that creates greasing, lubrication structure is the oil. And the thickener helps you to retain the oil in place. So when the oil comes out of the grease, it will oil the place, then the thickener will take it back again, will absorb it and store it until when it's needed. So no matter how hot the place is, the oil will not leak out. As the oil does the job of cooling and control of friction and wear, your thickener inside the grease will absorb it back and store it. So you can stay for a long period of time, even much more than the oil itself when you use only oil. That's what I say, extended lubrication. Then temperature stability. Depending on the formulation, grease can maintain its lubricating properties across a wide range of temperature. This is where grease plays a wonderful role. Where oil fail, grease will not fail when it comes to temperature control. So that's why grease also what up to now nobody has been able to replace grease in the lubrication industry, right? These are the types of grease. Then this NLGI means National Lubricating Grease Institute. These are the institutions that regulate the formulation of grease, right? They give us a table or a chart where we can mix our oil, additive, and your thickener in the right proportion, right? So when you follow that table, you get all these grease grades from 0, 0, 0, 0, 0, 0, 0 up to 6. These are the various grades of grease you have, right? Then from this first one, 0, 0, 0, and 0, 0 grades. Then this is 0 grade up to 1 grade. These are the oil, the more of a liquid, semi-liquid base of grease. Then from this 2 down to 6 are actually semi-solid base grease. So what am I saying? When grease in this 0, when you call it EP0 or EP1, when you say EP1, extreme pressure or extreme pressure 1, extreme pressure 2, extreme pressure 3, extreme pressure 4, 5, and 6. But when it is extreme EP0 or EP1, the amount of liquid-based grease. When it is EP2 grade, EP3 grade, up to EP6 grade, the amount of solid grease. And each one has where they can be used. Like EP000 and EP00, that's 30 of 20. is primarily used for lubricating open gears and gearboxes. Then when it is EP0 grade, it is used for lubricating open gears also, gearboxes or centralized lubrication system. When it is EP1, when it says centralized system, those of us that work in crane, if you are working in labor crane, we know labor crane has a lot of greasy joints because it will be very impossible for you to grease those areas that are not easily accessible, like the tower. There is a structure they put there. It's called centralized lubrication system or automatic lubrication system, where the lubrication is done automatically through another mechanisms that I will not talk about it now. So that oil that you put in there is called EP0. If you put EP2 on that machine, it will not work. It will cake the line. It will stiff on the line. So you only use EP0, at most EP1. If you go beyond EP1, you are looking for trouble because they are more of liquid base, even though they are called semi-solid. Then the EP1 grade is primarily used for lubricating those bearings or roller bearings operating at high speed. Can you see that? The EP2 grade, most widely used for lubricating anti-wear bearings operating under medium load and moderate or medium speed. The EP3, primarily used for lubricating anti-wear bearing operating under medium load and medium speed, as well as automotive wheel bearings, right? The grade EP, that is grade 4 grease, primarily used for lubricating bearing and shaft collars in water pumps and other high load, low speed applications. The EP5 and EP6, they are used interchangeably, right? Primarily used for lubrication under special conditions, such as bulb bill neck lubrication, right? Can you see that? So in oil and gas, we use EP0 and EP1, then EP3. In marine transportation, we use EP4 and this EP4 and this EP5. When you are working, those that have worked on this that propeller shaft, that oil, that grease you put there, that thick grease is more of EP4. All right. So they don't have where they are used, and there's a chart for that. And that chart was designed by these guys, NLGI. This one means National Lubricating Gear Institute, right? National Lubricating Greasy Institute. National, that is N means national, L is lubricating, G is grease, I is institute. They are the guys that gave that what we call it a flyer now, where you can do your selection. Then let's go to the next page. The consistency of grease is typically classified using the word National Lubricating Grease Institute. I've talked about just now. Grease ranging from 0 very soft to 6 very hard. When I say very soft, that is more of liquid, to 6 very hard, which is more of a solid, all right? This classification helps engineers and technicians to select the appropriate grease for specific application based on factors such as operating temperature, load, and speed. The next type of lubricants now is also solid. This is the third one, solid lubricants. Solid lubricants are solid substances that can effectively separate the surface of two bodies and thus reduce both friction and wear. These solid lubricants find extensive use in aerospace, in automotive, and heavy industry sectors, where they often outperform liquid lubricants under extreme temperatures, pressure, or environmental conditions. Solid lubricants find application in various industries, particularly in environments where liquid lubricants may not be suitable, such as high temperature and vacuum conditions, right? They are usually referred to as metal bearing in internal commercial energy, in your ICE. Cone or spacers are and even bearing sometimes serve as a solid lubricant. When you say this is a cone, this is a bearing cone. This is your liner bearing inside your engine, that's your engine bearing, engine crankshaft bearing, engine crankshaft bearing. That's look like a half a plate, a circle plate that you put before you put your collecting rod in your crankshaft. Is a form of like solid lubricant. Exactly. Then when you use your bearing also, it's acting as a solid lubricant, because you're not allowing your shaft to rest on the ball. Instead, you are allowing your shaft to rest on the bearing. There's sometimes you use Teflon, that look like a plastic, to create a cone and fix it in between your shaft. When such is done, that Teflon cone become a solid lubricant. Is that clear? Sometimes we use brass and copper to create bushing. Those bushing, when installed, they act as solid lubricants. That's what I'm saying, right? Where only oil cannot do the job, you now use what? Solid lubricant. Why are we using solid lubricant? Instead of you allow your shaft to die or your board to die, your bearing or that your bushing will be the one carrying the load, and instead it will be one that will die. But they are usually made of a softer material that will die first, so that your shaft and your bore will be free. So instead of replacing your shaft always, you only replace those your metal bearing or your solid bearing as going to be good. Then the next one now is your gas lubricant. Gas, when we say gas lubricant, is everywhere, even in your hand. When you rub your palm in your church, as you are clapping your church, there's a lubricant in between your hand. That is gas lubricant. You are trapping the air, and your air contains helium, nitrogen, oxygen, carbon dioxide, and others in the right proportion. All right. But in engineering, we say gas are compressible fluids. They are there to the principle of fluid dynamics and lubrication theory. This enables them to function as effective lubricants under specific conditions, similar to liquid lubricants. The advantage of gas lubricants are as follows. One, exceptionally low friction coefficients, often an order of magnitude lower than liquid lubricants. The minimum frictional heat generation at high rotational speed, crucial for precision machinery. Number three, negligible temperature increases during operation, maintaining thermal stability. Remember, I told us that lubricant does many jobs. Apart from friction, reduction, it carries away what? Heat. Am I right? Because it carries away heat, during your, maybe for example, when you are moving on the road, when your vehicle is moving on the road, especially your engine, even though you have your cooling step in your machine that carries away your excessive heat. I'm lost. Am I right? Hello. Can you hear me, sir?
We can hear you.
Okay.
Yes, we can hear you.
Okay, sir. So as I was saying there, when I will use it, for example, when you are driving your machine or your vehicle from point A to point B, your oil is your oil sump, helping to what? Do your cooling and your lubrication. At the same time, your radiator carry your water, that is helping to carry away excessive heat from the engine. But that excessive heat, as it goes to the radiator, as you are driving, the air is coming, right? Air entering, because air is coming, it's also helping you to push away the excessive radiator. So we miss the gas lubrication now. That gas lubricant is everywhere. It's in your vehicle, it's in your aeroplane, in your aerospace, it's also there. Because the aerospace passes through the air as it's going. It's making a lot of noise. He's trying to break away barrier in the air. Then your air itself is also helping to do a lot for the aerospace. What is the first thing it does? It helps to carry away excessive heat. And it also, because of the shape of the aerospace, the air helps him to maneuver well when it's on the sky and so on and so forth, right? It's essentially low friction coefficient, often an order of magnitude lower than lubricant. Number two, generation at high rotational speed, crucial for precision machinery. Number three, negligible temperature increases during operation, maintaining thermal stability. Number four, flexible operation across a wide range of conditions. Five, broad working temperature range from cryogenic to extremely high. When you say cryogenic, that is from a very cold to very high temperature. Then zero contamination risk, ideal for clean room and food processing application. Number 7, self-cleansing properties, as gases can carry away what particulates. And as I told us, anything that have merit also have demerits. Anything that has the good side must also has bad side. Then these are some of the limits of using gas lubrication. The first one, low density and viscosity, resulting in reduced load-bearing capacity compared to liquid lubricants. Limited application range, typically suitable for pneumatic devices operating within 17 to 30 to 17 kilopascal and hydrostatic bearings not exceeding 100 kilopascal kPa. Then the third limitation is higher precision requirements in bearing design and manufacturing to maintain thin gas frames for potential for instability at high speed or under fluctuating loads. This characteristics makes gas lubrication particularly suitable for high-speed, low-load applications, such as air bearing in precision metrology equipment, turbo machinery, and certain aerospace components. The choice between gas and liquid lubrication ultimately depends on the specific requirements of the application, including speed, including temperature, and environmental concentration. So we'll go to the next topic now. Sorry. Composition of lubricant. I have told that during our introductory stage, we told us lubricant consists of 3 things: base oil, or natural oil, or synthetic oil, then additives and thickener. All right. Then the first one, that base oil. Base oil is the fundamental component of every lubricant, typically consisting of 80% to 95% of the total volume, and serve as the carrier for performance-enhancing additives. Base oil are broadly categorized into 3 main types: natural oil, mineral oil, and synthetic oil. Am I right? These are natural oil, animal fats, and plant extracts. Mineral oil, these are mineral oil, 0W430. The one oil you use in your car, the one you use in your house, in your gearbox, the one you use in your industrial plants, that are all mineral oil. Then synthetic oil. So that this synthetic oil, this is your hydraulics that you use in running your hydraulic equipment. Most of those those oil are under this synthetic oil, right? I said under this base oil now, mineral oil derived from crude oil through refining process are classified in most countries, including ours, into 3 primary categories based on their molecular structure and properties. We have paraffin, we have naphthalene, and intermediary. When you say intermediary, that means a combination of paraffin and naphthalene makes your intermediary oil. When you say paraffin oil, these are oil characterized by high percentage index, good oxidation stability, and low pour points. Whereas naphthalene oil, base oil, are known for excellent low temperature, fluidity, and good solvency for additives. I think I should go to the next page. Right? I've already talked about this before. Synthetic oil. Synthetic oil is a lubricant consisting of chemical compounds that are artificially modified or synthesized. Synthetic oil is used as a substitute for petroleum refined oil. Synthetic-based oils are engineered through controlled chemical reactions, resulting in molecules with specific desired properties. The advantage of synthetic oil over mineral oil are these. The first one, higher chemical purity and molecular uniformity, superior thermal and oxidative stability. It can withstand any form of heat or coldness, and it doesn't permit your metal to form any other compound when it meets with the oxygen in the system, right? The improved viscosity temperature relationship, the extended service life, and enhanced performance in extreme conditions. And we told us that the only challenge is that they are very expensive compared to other oil, all right? This characteristics makes synthetic oil the preferred choice for high performance applications and represent the further trajectory of lubricant technology. Synthetic oil are currently indispensable in aerospace application and are rapidly gaining traction in industrial machinery. Additives. I told you that we have 3 materials or 3 components that we bring together to form your liquid lubricant. The first one was your base oil. The next one is your additives. Additives are minor yet crucial constituents incorporated into lubricant to significantly enhance specific characteristics or introduce new properties. They act as modifier, helping the lube to adapt to any situation and condition they find themselves. Functions of additives are as follows. Additives they are owner specific. Sometimes the manufacturer they will make their oil and add additives to it, and there's a plate or a template they will add to that oil or a manual where you'll be told what that oil is capable of doing. There's no one additive that can perform miracle. Every additives perform a particular function. So we have up to 10 kinds of additives that are added to oil. So that you can add more than 3 to or 4 to one oil. So that you can add just 1 to that oil. So that you can add all 4, all the 10 to oil in during the when you are making synthetic oil, right? But in our mineral oil, the one we use in our the one we commonly use, the maximum additive you can add is between 4 and 5. And I will tell you how those additives are made and what they are made to represent in your oil. The first list is your detergents. Detergent additives. When you say detergent, that means you already know what it means to wash. A detergent is more of a soap that helps you to wash. So when you add a detergent, the way you add an additive to oil that is detergent in nature, what you want to do is that you want that oil to be able to wash away the system at all time, so that there will be no impurities, no dirt in the system. It's a detergent primarily utilized in internal combustion engine to remove liquid and carbon deposit from cylinder walls and piston rings. They also effectively disperse gum and soot particles throughout the oil, preventing agglomeration and the formation of larger, potentially harmful particles. The next one on the list was antioxidant. Oxidation means the chemical reaction of oxygen with your metal to form ferrous of that metal. So, and it's very harmful in your oil. So when you add antioxidant to your additive to your oil, what you want to achieve is what this compound inhibit the oxidation process of the lubricating oil, thereby extending its service life and maintaining its performance characteristics over time. They work by neutralizing free radicals and breaking down peroxide compounds. You will not make that equipment, that metal, or you will not allow that chemical reaction that will form ferrous or that will form an oxide of that metal as going to be, right? That's what antioxidant does when it's added to your oil. The next additive is anti-wear agent. This will stop the wear, the corrosion of your metal or of your surface. All right. This one, when this one is added to your oil, when it's anti-wear, that means there will be no wear anymore. So they say these additives improve the oil's resistance to wear and scuffing by forming a protective film on metal surfaces. They reduce equipment wear, prevent seizing or sentry, and are particularly crucial in high pressure and high temperature application. The next one is oiliness agents. Oiliness is also known as what friction modifier. They help to prevent. These additives reduce the friction coefficient and enhance lubrication performance by forming a tenacious adsorbed film on metal surfaces. This film provides boundary lubrication under severe operating conditions. The next one is metal deactivators. They form a passive film on metal surfaces to minimize the corrosive impact of the oil on the metal and inhibit the catalytic oxidation of oil by metal ions. This is particularly important in systems containing copper or its alloys. To deactivate, this one is almost like a anti-wear agent. All right, they perform the same function, but this for anti-wear is for every metal. But this metal activators is for specific alloys of metals like coppers. As after copper, this they are not ferrous metal, but any other metal apart from ferrous. We use a metal activator, right? Like your copper, your bronze, your brass, and the rest of them, right? Even aluminum. We use on the right. Then this one, viscosity index improver. I told you that this viscosity index is ability of your oil to withstand wide range of temperature variation. So this improver, this viscosity index improver will help the oil, as the oil was only able to withstand between 0 and 30 degrees centigrade. If by the time add this, oil will not be able to withstand between 0 and 50, and so on and so forth. That means it has improved the oil viscosity index. It is now telling the oil the range of temperature you can withstand before you begin to what this polymeric additives increase the oil's, enhancing its vascothermal performance. They expand at higher temperature, counteracting the natural tendency of oil to thin out, thus maintaining adequate lubrication across a wide temperature range. Then rust inhibitor, I'm always saying, right? But they are meta specific. They have metals that you can also use them for, right? These additives act upon the metal surface to prevent rust or corrosion when in contact with water, all right? They form a protective water barrier that repairs the pour point depressant. When you say pour point, this is the temperature at which liquid will begin to start flowing. All right, every liquid will start to flow from like to better understand this. When you put your honey in the pot, if you turn that pot, it will not flow. But when you heat that honey a little, so let me use butter. Your butter, if you put your butter is always thick, it's always in solid form. But when you put that butter in under the sun, we tend to make it flow. So that temperature between when that butter will now begin to start flowing is what we call the pour point in your lubrication step. So pour point depression, this one means it will help you to increase the temperature at which your oil will start flowing, or you have to improve the temperature at which the oil will start flowing, because the purpose of your lubrication is to make sure as you start your equipment, the oil will begin to flow immediately to do the job of lubrication, the job of what removing controlling your friction, control your rate of wear and rest. All right. You know, when you start equipment, when you start, for example, your normal engine, and you start it, the first 90 seconds, the engine will rev. If you realize it will idle. You don't throttle it the first 90 seconds, because that first 90 seconds, your oil is not circulating in the sump. All right. So some oil too, after that 90 seconds, they will not flow based on the environmental condition. But when you put this pour depression, it will control the oil. It will command you so that by the time you start the equipment, that 90 seconds is enough for the oil to regain momentum and start flowing. That's what this pour point depression does. They lower the oil's pour point by modifying the crystallization of particles at low temperature, thus improving the oil's low temperature fluidity and pumpability. This is crucial for cold start performance and operation in low temperature environments. I just repeat now, right? So by the time this is added, then the oil that is sluggish to flow will begin to flow as soon as the need arises, right? Then deformant. Some oil foam. Some oil they will be foamy, especially when they come into contact with water. Especially when it's used, when the cooling state fail, it will begin to foam. And before you know it, it might char. When I mean it might ignite, it might reach its flash point, and the fire might burst out. But with this your deformant, you are able to control the rate of formation in your oil in the cooling system, right? This deformant additive alter the oil's data to foam by this surface tension and causing surface bubbles to burst quickly. This prevents air entrapment, which can lead to reduced lubricant effectiveness and increased oil. The next page, let's do the next one. The next one was emulsifier and anti-emulsifier. Please, can you please mute your mic, please? Thank you. Emulsifier and anti-emulsifier. To emulsify, emulsifier are used in emulsifying oil to form a uniform and stable emulsion, with water. To emulsify, you are making the oil. There are oil you want them to what? To mix with water easily. There are other oil you don't want it to mix with water at all. So that was what this emulsifier to emulsify means to mix with water easily. The anti-emulsifier means you don't want it to mix with water. Depending on what you want. If you want the oil to mix with water, you use the emulsifier additives. If you don't want it to mix with water, you want it to separate itself with water. No matter how the water mix, touch that oil, it will never mix. They will separate. You use anti-emulsifier additives. All right, that's what I was saying. Then the next on the list is what thickener. All right, thickener is the third component, or the third, yes, I will call it component, that the third item we use when you are making your lubricant. All right, I will tell you when to use it. For oil, for liquid lubricant, you use only base oil and additives. But when you are making semi-solid lubricant, especially grease, you use all three together. All right, that is the difference between grease and oil. For oil, for liquid, you use only two, which is base oil and additives. But for grease, which is semi-solid, you use all the three, which is a complex system of thickening spread in base oil and not structure under
It seems we are experiencing network problem. Be patient and wait for Junior while he comes up.
Empty here too.
It's the network problem. He will come up soon. We are glad you're back. Yes, we are glad you're back.
Thank you very much for your patience. But I'm ticking, am I right? This is too loud. Glory. Welcome. It's like I'm not hearing myself again. Where's the
We can hear you. We can hear you.
Okay,
we can hear you.
Yes. Okay, thank you very much. I said thickener are a critical component of lubricating grease. Sorry, let me put it on here. Let me see this one. Don't go for it. You want PA this now, right?
Okay, I'm just here.
Yeah, still there, right? I'm sorry, right? So as I was saying, thickeners are a crucial component of lubricating grease. When thickeners is added to base oil and additives, the product is called grease. This thickener distinguishes liquid lubricant from your semi-solid lubricant. Lubricating grease is a complex system composed of thickeners spread in base oil along with performance-enhancing additives. This unique composition results in a solid or semi-solid substance with properties capable of withstanding high load and maintaining its structure under shear stress. Thickeners are formed by the reaction of alkaline and organic acid. When you say alkaline is more of base, am I right? And in science, when base and acid are mixed together, they form salt and water, am I right? So that salt that is formed is called the alkaline. That's why they say alkaline is what? It's a salt of acid. Salt of stearic acid is called thickener, right? Because from here they say thickeners are formed by the reaction of alkaline and organic acid, which is stearic acid. So it will be right for us to say that thickener is a soap of an acid-based reaction or a soap of stearic acid. Is that clear? What is it? What is not speaking here now? Oh. Thickeners play thickener plays many roles in grease formulation, significantly influencing several key properties. One of such roles is what consistency. Thickeners determine the grease firmness and flow characteristics, typically measured by NLGS. Drop point, the temperature at which the grease transits from solid to liquid state, crucial for high temperature application due to what high drop point, ability to repair water and maintain its structure in wet environment. This thickener, how it do that? It acts as a protective layer, a coating. The oil is inside the thickener. The thickener, the grease you are seeing, the oil is inside, and it is that oil that does the what lubrication. The thickener only help what is acting as a container. The same way you have your sump is that how you have your thickener. Thickener act as a container that house the oil. It only provides the oil when the lubrication is needed. After lubrication is completed, the thickener will absorb the oil back again and store it. And that container is so much that is able to ensure that water doesn't mix with that grease, with that oil, even though the system is under the rain or under the sun will not affect the oil, nor the rain affect the oil. Sometimes even the dirt, your dust will not even of water, sun, and then dust. But when the equipment is working, the grease has a way of, I don't know how it is done. It's so miraculous. The grease is squeezed out the oil at a particular temperature. Then the oil will now carry away the heat, and do the sliding to make sure the friction is what minimized in that rubbing part. When upon completion of that job, the thickener again will have to absorb the oil from the surface and we store it for another day. That is exactly what thickener is doing. That is already say water resistance. That is why it's able to do this water resistant stuff. Then number 4, load capacity. Certain thickeners, particularly soap-based ones, can enhance the grease ability to withstand high load and pressure. That is depending on the mixture now. How you make your ratio, how you ratio your oil, additive, and grease. I told us that grease, oil, and thickener. I mean, oil, additive, and thickeners are mixed in the ratio either 18-10-10 or 18-5-15 or 18-55 and so on and so forth. The way you mix it will determine the performance capability of that what grease. That's what is clear, right? Then shear stability. Thickener influence the grease ability to maintain its consistency under mechanical stress, no matter the load, no matter the force, the negative force no matter the negative pressure that is being introduced. Your thickener, the right thickener, when the thickener is mixed in the right proportion, the grease will be able to withstand that negative pressure. Then oil release and blend, and this is what oil release and bleed. Look at this one now. The thickener network controls the rate at which base oil is released, affecting lubrication efficiency. It acts as a reservoir for the oil. I just made that one out. This one is here. The thickener acts as oil can. What your oil can does in your oil, in fact, it even act better than oil can, because oil can release will be used when the oil is finished in your oil can, you put extra oil. But in your thickener, the oil is released. When the oil finishes job, the thickener will absorb the oil back again and store it for another day. Can you see how better the grease thickener is compared to the oil can? So your oil can is like your thickener in your oil. You store your oil, you release the oil. When the oil is finished job, the oil will either go to the sun or you will throw it away. But your thickener we release the oil. When the oil is completely used, it will take it back again and store it for another day, for in the case of grease. So which means you're taking it now is actually what doing multitask in your lubrication system. So this is what they say: oil releases and bleed. The sticking network controls the rate at which base oil is released, affecting lubrication efficiency. It acts as a reservoir for what the oil. The selection of appropriate thickness is critical in tailoring grease properties to specific application, from high speed bearing to heavy industrial machinery operating in the challenging environments. The role of a lubricant. What does lubricant does in our industry? What does lubricant does in our equipment? What they do in our machinery? At least we have a machinery on our own. 8 of wheel here. We have Mexico, we have machine, we have a part of neighbor generator. So which means almost every that is in this platform, we use a lubricant in one way or the other. So what is the role of this lubricant? The first is that the primary function of a lubricant are this first 7: reduce friction. It doesn't stop friction, it only reduces what? Friction. All right, it controls friction. He's not saying there's no friction anymore, but that rate of wear will minimize. What would have get burnt in less than 4 weeks, by introducing lubricant, it can stay for 1 year or 2 years. All right, that's what the first job of a lubricant. It prevents wear after you reduce the friction. Once there's no friction, wear will be prevented. Exactly. Then number 2, it protects the equipment from what? Corrosion. As well as now, corrosion is now being aware of what our equipment. Once there's the right lubricant used, that corrosion will not be there. All right. Then control temperature. There's heat. Yes, especially in your hydraulic system, your lubricant carry heat away, and there's been all right. Then even your IC lubricant does not only do the job of a lubricating of a lubricating. It also help what to remove excessive heat, taking the heat from your connecting rod to your engine block, for example. Then for that engine block, the water will not remove the heat from the engine block to your radiator. Can you see this? So they work together, they work in synergy. The next one now, control contamination. Carry contaminants to a filter or sump. During your filtration system, during your fresh oil, as put the oil in your sump, that fresh oil, the way you start your engine, the oil is thrown up and down, carry away heat. Then the incomplete combustion in your chamber will form carbon. The carbon and the lubricant has the power to carry those nonsense to your sump. Then during the next cycle, because the oil will make to pass through the filter, those dirt will now be transferred to the filter. The filter will absorb them, then remember making the oil to become clean. It goes again, carry more dirt, take to the filter and store it in the filter. It goes again continuously until when the filter becomes very, very dirty. Then during PM, you change your filter, then you change your oil. So that is what your lubrication also does, all right? Then the next one is what? Transmit power. There's other hydraulic, all right? Then the last one, provide a fluid seal. I've explained that before. Because lubricant act as a third component in your system. For example, if you have a shaft and you have your shaft and your bearing, there is a little tolerance fit, a clearance in between them. That clearance, when the engine is working, when the shaft starts rotating, oil will feed that clearance. Once the oil feed that clearance, it no longer allow external particles to move from the outside into the engine, right? Yes, I know there is seal there, but without a seal, there are some area where even if there won't be no need for seal, only the grease will be there, and that grease will help you to seal out the structure so that no dirt can come in. All right. Then sometimes the functions of reducing friction and preventing wear are used interchangeably, but they are different. Wear and friction. Sometimes we think they mean the same thing. No. Friction and wear, sometimes in engineering, they are not the same, but in the real life, we use it interchangeably. But in engineering, in the world of topology, they mean different things. Friction is different, wear is different, right? Then we say why friction is the resistance of motion, wear, on the other hand, is the loss of material as a result of friction. Without friction, there will be no wear. It is when there's friction that there will be wear. So you can control friction, to mean you control wear. All right, it's like say hazard and risk. Hazard and risk, to some persons they are the same, but in the real life, in the workshop practice, they are not exactly the same thing. The presence of hazard might lead to risk. I mean, how I put it now, risk and hazard are not exactly the same thing, right? Why hazard is the presence of those things that have the potential to cause harm. Risk, on the other hand, is the likelihood that this hazard causes harm. Can it cause harm or not? All right. Then we also, while friction is the presence or is that negative energy, that negative pressure, that negative force that retard your motion. When motion is retarded negatively, it will lead to wear. All right. It will create hot heat and so on and so forth. Whereas wear, on the other hand, is the loss of material as a result of what? Friction, contact friction, and fatigue and corrosion. Apart from friction, other things can cause wear. So you can actually have a frictionless environment and wear will still take place. All right, and you can actually have wear too without friction. And you can also have friction without having wear, like your fluid friction. Fluid friction, there's no wear associated with it, and so on and so forth, right? The role of a lubricant continue. There is a significant difference between friction and wear. In fact, not all that causes friction can cause wear, like your fluid friction. We have sliding friction, rolling friction, and fluid friction. Only sliding and rolling friction can cause wear. Fluid friction cannot cause wear, and not all that causes wear can cause friction, e.g., cavitation erosion. Doesn't cause friction. This one doesn't have as a lot of friction. This is a cavity erosion. This one, when there's air in your system, when there's air in your system, it can begin to attack your inner structure of your. When you say erosion is the erosion is just like corrosion. Why corrosion attack the external part? Erosion attack the internal parts, as in your pipe. What happens on your external part of your pipe is corrosion, but what happens in your internal part of your pipe is erosion, right? That is the erosion and the corrosion. They are both wear, all right? Then reducing friction is a key objective of lubrication, but there are many other benefits of the lubricating process. Lubricating films can help prevent corrosion by protecting the surface from water and other corrosive substances. Lubricants help in controlling contamination within systems. Lubricants work as a conduit in which it transports contaminants to filters where they are removed. I've said that before. These fluids also help in temperature control by absorbing heat from substances and transferring it to a point of lower temperature where it can be dissipated. I've also explained that just now. I want to use your engine as an example, that your lubricant will help you to carry heat away from your conducting rod, your internal structure, and transfer those heat to your engine block. Then by the time your water or your cooling system, cooling the fluid passes through this area, it will not carry the heat from your engine block or the top cylinder as it be down to your radiator, where your air will blow into your radiator and help the radiator to carry the heat now to the atmosphere. Can you see how the lubricant does that beautifully? Then the next, how grease work. We are talking about how the lubricant work, the oil work. Now let's talk about how grease work. Understanding how grease works is vital to determining the suitability for specific applications. Here is a brief overview of how grease work. Grease consists of base oil, a thickening agent. The base oil provides lubricity, while the thickening agent gives grease its semi-solid consistency. When grease is applied to the surface, it forms a film that As the equipment operates, the grease film slowly releases the oil, ensuring continuous lubrication. And any excess oil released by the grease film is reabsorbed by the thickening agent.
Our trainer has gone off again. Let's kindly exercise patience. Thank you very much.
Oh, don't wait, just that's gone.
Yeah, unmute yourself. Okay, you're on.
We
Sorry for
can
that break in transmission, right? Can you see?
we
Can
can
you
hear
hear
you
me?
now, sir.
Okay. I
Yes,
said,
yes, we can.
okay. I said, remember that regular maintenance. And where was I? Where was I when I went up? Was I here already? Madam and Madam Lola, am I in the right page, or should I go back?
You're on the right page. You're on the right page. I
said,
think you're
remember,
on item 3.
okay. I said, remember that regular maintenance and appropriate selection of the right grease and grade are crucial for optimize the performance and longevity of your machinery and equipment. Then the next slide, then grease grade or grades of grease. Grease grades are established by the National Lubricating Grease Institute for grease consistencies. The NLGI consistency number rates grease hardness. NGL grades range from 000, that is 30 semi-fluid, to 6 very hard fluid. Then the lower NLGL numbers indicates softer grease, while the other number indicate the word a bit solid. When the number is from 000 and 00 and 1, so that 2, they are more of a soft grease. When they soft, like almost liquid-like. This is grade 000, grade 00, grade 1, and grade 2. This one means the grease are almost what liquid-like. Exactly. This one, sometimes you don't need the brush to apply them. You pour them. Sometimes, especially when it is 00 and 0, EP1, EP2. This will be, we shall also have EPA, that's extreme pressure 000, extreme pressure, that's EP00, that's extreme pressure 00, the EP1, who is extreme pressure 1, the EP2, extreme pressure 2. But we are not putting that EP. We assume we already know that is how grease are what categorized. So EP000 to EP2 are very, very soft grease. When you say soft grease, they are almost like liquid. All right. So sometimes we use them where we have automatic system of grease application. Then EP3 down to EP6, 3, 4, 5, 6, they are more of they are really semi-solid or solid grease. These 2, 3, these 3, 4, 5 are more of semi-solid, but this 6 is almost solid. When I mean solid, it's very, very thick. In fact, if you throw stone inside it, it will just be on top. But this EP0 to EP1, if you throw stone on it will suck inside. If you just go inside, you will see it will cover the stone. That's the difference between this one to this 0 to 2, and then this number 6, all right? Then we have 8 grease category, 8 grease grades. 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 kind of grease that we have, all right? under the semi-solid lubrication system, right? Then equipment lubricant. Do we stop here or should I continue? Hello?
We can
Hello?
hear you. We can hear you, sir.
We
can hear you.
Can hear you.
It's 7:57. I would have suggested we stop here so that we can ask questions. So it's almost already just 3 minutes to 8. I would suggest we stop here so that we'll start further tomorrow. This to give us a chance to ask questions from what we have learned so far. Is that okay, Barros?
Thank you, sir,
Yes,
for the wonderful and insightful.
Yes, sir. Yes, sir. We're excited.
Network wasn't much of a problem.
Okay, yes.
Please, if you have any questions, you can raise your hand and ask, or you send it to the chat box and then it will be addressed by the trainer. Thank you very much.
Okay. So who is answering the first question?
Kindly ask your questions.
Hello?
If you have any. Send them to the chat box or you raise your hand and you'll be called on to ask your question. Nobody is asking a question. Engineer Stanley, do you have any question for the participants?
I will always have a question. Yes, sir. Yes, ma'am.
If they are not
I'm raising my
asking.
hand. I'm raising my hand here.
Okay.
Okay.
Let's have a question.
Mr. Nuruddin, you can ask your question. Thank you.
Yes, good evening, our facilitator.
Good evening, sir.
We appreciate your effort and your explanation.
Thank you, sir.
So my question goes thus. Different machines uses different oil. So what are the determinants? What will determine the type of oil to be used for a particular machine? For example, what I mean is this: there are instances where it will be recommended to use grease. There are instances where it will be recommended to use ordinary oil that is not as thick as grease. Even among the grade of oils, you have different types. So what are those things that would be like a determinant to choose the type of oil that we want to use for a particular part of a machine? Thank you.
Engineer Stanley, are you here with us? Are you still on the call? Engineer Stanley. I think the next. We can't hear you properly.
I get.
I think he's having network problems.
Hold on.
Okay, he's back now.
Oh. Hold on, let me log in again.
We can hear you, sir.
Okay, so can you hear me? Can you hear me?
We can
Your question
hear you.
is okay.
Yes, I can
Your
hear you.
question is how do I know the oil or the lubricant I should use my equipment? Am I right? I said
Yes,
that would have been
sir.
tomorrow's topic where we are dealing on lubricant selection. But since you have asked a question, I will just give you a piece of the iceberg of what we are expected to know tomorrow. We have 3 things control. How that is I'm hearing myself. Can you hear me, sir?
I can hear you. I can hear you, sir.
Oh, okay. The first thing that you consider is what the OEM advice that you use. That is the first one. The next one, even though if OEM says uses that kind of oil, the environment you are working, the atmospheric condition of that environment will also play a role in what you will use. All right. Then
Yes, sir.
there are times when you have started using that kind of oil and you find out that you are spending more. You want to see how you can deviate from normal. There's need to carry out what's called oil analysis. You take your oil to the lab, you check what that oil performance is, then you now use your oil chart to look for alternative oil that can give you exactly or close to what you are already using. But I understand that there are some equipment due to their age, there is no need you using the right lubricating oil again to save cost. But you don't just do that using your head knowledge. You must pass through lab, through oil analysis. It must not be you. What is why you should take your sample to the lab? They will tell you the kind of best alternative oil that is a bit cheaper, but that meets the need also of that equipment. All right. So this will be explained tomorrow, right? That is the best answer I can give to you right now, right?
Thank you, sir. Thank you very much.
Okay, sir. God bless you.
Yes.
So any other questions? If you have a question, just kindly indicate.
Well, I think we don't have any other questions since nobody is asking. So in the absence of none, this is past 8. I think we'll start calling it a day. So our participants, don't forget to follow up with updates on the WhatsApp platform. See you same time tomorrow for another live class. Good night all, and thank you. Thank you, Engineer Stanley, for the wonderful training.
Good night.
Thank you, Engineer. Thank you, Madam. Bye now.
Thank you very much,
Thank you.
I'll touch your hold.
Thank you very much.
Would you to get some?
Good night, everyone. Thank you.